Hello, everyone. So, today we are going to discuss one more very beautiful problem. And the problem is container with most water. So, this is also a very medium level common problem. This problem is actually asked in direct or indirect forms. It has different versions. This problem, when we solve this particular problem, we will get to know the idea of playing around uh, problems which can be asked similar to this, right? So let's go and discuss this particular problem. Container with most water. So you are given an array integer, okay, of height of length n. There are n vertical lines drawn such that the two endpoints of ith lines are I comma 0 and I height of I, right? So mathematically, if I convert all these numbers into here, so for example, if height, like at height 0 index, it is 1, it means this is the y level coordinate for that particular for that particular coordinate. So I will be 0, and the value for that I, this is 0, means x axis, and y is like y axis, so which is 1. Then similarly, this I comma 0 is where you are talking about again a coordinate. So this will be 0 comma 0. All right. So 0 comma 0 here, and then 0 comma 1 here. So it is reaching here. Then the other point is like it moves there. So I will move to 1. So 0 comma 1. And then the index is the 0 comma 8. So it will write here 0, like x axis 0 and y is 8, right? Similarly, x-axis 0, y is 6 over here. So that's how you can correlate all these coordinates into numbers. Now, what is this question is asking about? So find two lines that together with x-axis form a container such that the container contains the most water. So you just need to think of all this in a type of, uh, in a way so that you imagine this as a container. So let's say you see this shaded portion, right? So this is what they are trying to ask. So you have to find out the container which contains the most water. So, for example, this red one and this black one, if you choose this container, so whatever water it contains, it might be less than the water if you choose this container, and I mean this height bar and this height bar. So the water which is here is more than water which will be stored here. All right. So uh, that is the reason we have to. It means we have to calculate the water inside every single bar or the collection of bars. So you have to retain the maximum amount of water a container can store. So yeah, this is the problem. So before I go into this particular problem, I would like you to think on this, like what should be the brute force or way you can think, and then we will talk about this a little bit, 1 or 2 minutes to discuss about the brute force solution, and then we will quickly jump into the optimized one, right? So let me go and quickly write the code for this. So I will go IntelliJ right here, class. It will be container with container with most water. Okay. And then I will add my class level comment, which is I copy from here. All right. And then I copy some input so that we know. Sample, yes. So yeah, this is how it looks like. Now I will start coding the problem, but before I code, I will actually try to discuss the brute force approach. Okay. Uh, so what is the brute force approach? So in brute force approach, what is coming in my mind is that let's go and see this particular picture again. Okay. So whenever you have problem like this, you have to design something. As I said, you can find out the coordinates x-axis, and then this is the height, like how high they go, and this is on the x-axis where they will start it, right? So these are the coordinates. You can make some picture like this, and then you can start thinking. So what? Indirectly, you would check every possible pairs of heights in the array, right? Every possible pair. So what does it mean? For each pair of height I comma j, each pair of height I comma j, where I is less than j, you calculate the area. What you do? You calculate the area. So when we say we calculate the area, what does it mean? So it simply means that you have to calculate the area of all pairs of height where I is less than j. So when we do that, we will be able to find out, uh, the exactly. Uh, okay, so let me quickly explain you with an example. Then it will be easy for you to understand, right? So when it talk about this, for example, let's say this is the height array. Okay, uh, so if I straight away say that we need to check every possible pair of heights I comma j where I less than j, and we are going to calculate the area. And area, as for every rectangle we have, uh, we calculate the area like length into breadth, right? So when you talk about L into B, which is the area of a rectangle, then you need a length. So length would be like, for example, if you talk about this is the length, and for these two heights, this is the length. For these two bars, this is the length. This is the length. This is so for every pair. So pair could be these two pair, and then this red and this small one can also be a pair. So for every pair, you get the area. And once you get that particular area, then what we will do, we will actually calculate the area and track the maximum area found. You get my point? So first thing which we have to do, we have to find out the area for all possible pairs. And whenever we say for all possible pairs, what does it mean? It means you can choose this bar and then this red bar. Okay, and because this is also a pair, and you can find out the area of whatever rectangle is possible. So you see this rectangle is possible. So always remember, when you try to find out the area, so area would be, let me write, like for example, area is what? Area is equals to L into B, right? So when you say L into B, your L is going to be length and breadth is going to be, how width is that. So length would be this and then breadth would be this. So always in all the cases, my min of height, which is like height of I, okay, comma height j, and then what do I have to do? Min of height this multiplied j minus I. All right, this is giving the area. So this is giving you the length, and this is breadth. Okay, so why breadth? You see here j, this j. Sorry, I just this. Um, this if you see this particular rectangle and this particular rectangle, so you know that if I try to make a rectangle for which I want to find an area, so you have to choose the minimum one, right? So this minimum one is giving you, will give you, get it from here. And then when you try to find out this distance, like from here to here, the horizontal, then you do j minus I. Let's say j is here and then I is here. So in short, you have to have two nested loops which will try to find out the area, and then you keep on storing that particular area in somewhere so that you can track the maximum area found. And that maximum area is nothing but is the maximum water that you can contain between um, between two bars, right? Between two heights. So return the maximum amount of water a container can store. So container is, of course, can be created using two bars. You take these two bars, container can be created. These two bars, a container can be created. So I think it's pretty much clear what is this brute force solution all about. In brute force solution, we are talking about two nested loops. And because we are trying to find out all possible pairs of which we are going to find out the area, and once we do that particular area calculation, we just track maximum area found, and then that will be the answer. And remember, area calculation is this, and you understand like why I'm doing minimum, because for example this and these two bars, this is the minimum. You can only make a rectangle, you can store only water till this size, right? So you have to take the minimum one. And this j minus I is what? Let's say j reaches here and I is here, so j minus I will give you the width. So that's how it particular works. Now, this nested loops O of n square, right? Can we do it in a better way? Yes, we can do that in a better way. How? We can actually take the advantage of two pointer approach here. So you will, what we can do, we can use two pointers left and right starting at opposite ends of the array. Okay, this will allow you to reduce the problem size as you progress, avoiding the need to check every pair of heights. So in previous brute force approach, we were doing every single iteration for all the pairs, but if you start your left and right indexes and you start at opposite ends, so you reduce your problem as you progress. So you do not need to check every pair of height. The area is calculated at each step, and you move the pointer pointing to the shorter height inwards, hoping to find a taller height that can increase the area, right? So this is very important. So once you get the area at every step, what you have to do, you move the pointer pointing to the shorter height inwards and hoping to find a taller height that can increase the area. So this is the trick which will solve the particular problem in O of n time complexity, right? Where n is the length of the height array. So let's code this particular problem in optimized way. So I will go quickly again here and start writing the code. So this is my main method, as I usually do. Input, logic, output. Okay, that's good. And then what I have to do, I just need to input is something which I can copy straight away. It's int height is equals to, I will copy this array. Here we go. And then I also say int, all right. Now logic will be int max area, okay? Or you can say max water is equals to max area, right? Mathematically it is nothing but the max area. And here I pass height array. And then over here in the output, what I have to do, I have to print my maximum water is max water. So that's how it works. I would not take much time and quickly jump into creating this max array method. Okay, create this method. It's right here. Now, as I said, int left is equals to 0. All right. And then int right, because I'm starting from two sides, it will be height dot length minus 1. All right. So this is where my indexes are. I am taking the advantage of this, like starting from both sides. And then y left is less than right. Perfect. What I need to do, I need to calculate area. So for area calculation, you know that it's something width is important. So width is right minus left. As you know, j minus I you did in the you remember I talked about the brute force, right? Now what is area? Integer area is equals to math dot min. And you also know why I'm doing this, right? This is also important to understand. These are easy and easy things, but yeah, sometimes we forgot why we are doing this. So we need to choose the minimum height, right, of whatever index we are, and then it's something where we need to multiply by width. All right, and this is the area. Very simple mathematical formula. And now what we will do, over here, we need to also make one variable which is called max area. All right. Because we need to maintain the max area, and that is the result. So what I'll do, I'll check max area should be, we can use if, but I will prefer to use this math.max because I just need to do area, uh, max area, comma, area. Okay. And every time it will update it. And there some conditions which will be which is responsible for my loop to work. So height of left, if it is less than height of right. All right. If that is the case, what I'll do, left plus plus, else right minus minus. And there I return max area. Yeah. So uh this is very simple when you go for optimized and easy to code. You just need to understand a bit of like is why we are going this particular solution. Okay. So over here, I think I would be explaining it one more time why we are doing this left, how we are maintaining this, right? So why move left pointer when height of left is less than height of right? So if height of left is less than height of right, this means that the left side is the limiting factor for the area, right? Since the area is determined by the shorter of the two heights, if it is the limiting. So by moving the left pointer to the right, meaning left plus plus, we are hoping to find taller line on the left side. This could increase the area if the new line is taller than the current height left. Moving left pointer towards right means we are keeping the right pointer fixed and trying to find out the better height on the left side so that increase the minimum height, thus increase the area. Why moving the right pointer? Okay. When height is left greater than, meaning just opposite condition. Why we are doing that? So when moving right pointer to the left, what does it mean? It could potentially find a taller line on the right side. This gives us a chance to increase the minimum height since the area depends on the shorter of the two heights. Moving the right pointer towards the left ensure that we are still considering the lines with a larger width but are attempting to find a better height on the right side. So this is the reason why we are doing left plus plus and right minus minus. So this is actually how so idea is always try to improve the limiting factor. The smaller of the two heights by shifting the pointer that is currently at the shorter height. This process reduces the width between two pointers. Okay. But ideally, by finding a taller height, it compensates for the reduction in width and increases the area. Let me run the particular solution and then see how it works. Okay. I say it's 49. Yes, it is good. Let me change it the set 1 comma 1. Run. It's 1. It looks good. Let me copy the solution and paste it on here. Okay, and submit the code. It is accepted. Let me submit. That's good. So solution is accepted. Thank you very much. I see you in other video.